and 2 assignments. Depending. Sometimes I'll just give assignments, sometimes I'll just give test assignments. Then end of semester exam constitutes what? 75%. These ones you know already. Okay, so 25 is 75. I'm sure you have the last group to do this 75, 25. The rest are not doing what? 50-50. You were fortunate enough. I have this Zimbabwe University module. Okay, as you can see, we are the authors. Okay, you can see that the authors is who? Yours truly. And Dr. Mataris, we are the ones who wrote this particular module. So you won't be surprised that I'm going to use the same notes. Okay. So if you get this module, I think I've put it already on WhatsApp. So if you just read through, you're able to get a distinction. Okay. Oh, you said decision of first class. The ones. Okay. So now let's go into the first chapter straight away. I'm trying to look for the PowerPoint. Okay, the first chapter is just an introduction to econometrics and its role in Zimbabwe. Introduction to econometrics and its role in Zimbabwe. Okay, that's the first chapter. Most of the sections, if I can just summarize, most of the sections, it has to do with how to deal with the assumptions of GLM, general linear models, or when you have a linear model, how do we deal with each and every assumption? Let's say we have a model y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus the error term. We just say epsilon t. Okay. If you have this particular model, what are the assumptions you have done it in the equation 1 and equation 2? Or apply statistics 2 and the equation. What are the assumptions? Just put your hand to say, because if you say together, I want to hear anything. If you know any one of the assumptions, there are many assumptions. 5 plus assumptions. What are the assumptions of this together? Yes. Error terms, it is what? Normally distributed. What do you mean? And variance? Sigma squared. In other words, we say variance is what? Constant variance. Okay? You don't have to write. I'm just going to say this. And the notes I've given you already. So this is one of the assumptions. What about the other assumptions? Other assumptions. Let's do with the error terms again. So say they are normally distributed. Then number 2, they have a constant variance. What else? Error terms. independent. Understand? What else? What are the assumptions? What are the assumptions? I'm asking you a question. What are the assumptions? Hey, did you pass the question? Did you pass the question?
takarisa takazorora.
What are the assumptions? I'm asking you. What are the assumptions? X are what? Huh? Are independent of each other. Understand? What about if they are dependent on each other or there's a perfect correlation? What do you end up with? What problem?
Multicollinearity.
What?
Multicollinearity.
Multiple correlation. That's all. When these xi, the x's, are dependent on each other, we end up with a problem called multicollinearity. What about if the variance is not constant? What problem are we going to have? What problem? Because we said the variance is constant. In other words, we said there is what? Homoscedastic. Are we together? There is homoscedastic. But if there is no constant variance, we say there is what? Heteroscedastic. Are we together? In other words, there is non-constant variance. So there will be a chapter on multicollinearity. There will be a chapter on what? Heteroscedastic. There will be a chapter on what? When the error terms are not independent. We end up with a problem called what? Autocorrelation. Autocorrelation. Are we together? Then the xi's and the et's, there is also no relationship between the two. Because if there is a relationship between the covariance of xi's and the et's is not there, then we end up with a problem called what? Contemporaneous correlation. Are we together? So we are dealing with these chapters. If you want to try again, we just tell you. First chapter, okay? Fundamental concept of economics and statistics. Then structure of an economy. Then definition and scope of econometrics. Goals of econometrics. Some econometric and time series models. Then causal models. Then time series models. Then non-stationary models, that is the I1 series and test for stationarity. Then the spectrum and its application in econometric modeling. Then steps in econometric modeling. Then the role of econometrics in Zimbabwe. Then we end up by summarizing the unit. Okay, yes, that is as simple and basic things. Let's start with the first one, the concept of economics and statistics. The concept of economics and statistics. Okay, so in order to appreciate the definition and role of econometrics in development, it is necessary to understand the fundamental or basic principles of what? Economics and statistics. For you guys, you don't have any problem because you've done a little bit of economics, you've done a little bit of statistics. So this course should be quite simple for you, as I mentioned before. Okay, definition. What is the economy or the economic system? Okay, I will define the economy or the economic system of a country as the totality of all activities that are concerned with the production, the distribution, and the consumption of goods and services. That's the definition of economy and economic system. Okay. Some of these definitions you need to know them because I'll ask you to define economy or define economic system? What do you think? It's simple. You can answer that one. Now, the state of an economy is governed by the amount and the nature of available resources. Okay? The amount and the nature of available resources, i.e., land, that is the minerals, the trees, and so forth. The capital, that is the money or the machinery. Then labor, that is human resources. And also the entrepreneurship, i.e., skills of the people running the economy. Okay. If I may ask some people, here, you live here in Zimbabwe, given all these things, what do you think is the problem here? Why is our economy? It's just a discussion. Just a discussion. And this person is entitled to his or her opinion. What do you think? Let's start with land. Let's start with land. That is the minerals, trees, and so forth. Do we have them? Yes. Do we have them? Yes. Okay. Capital.
We don't have capital.
Capital.
Yes.
No, yes.
Just put it significant.
We have the capital. Yes. I'm not looking at individuals. I'm looking at Zimbabwe.
The nation as a whole doesn't have capital. Most expect investors to come here and
Let's
invest.
listen to him. We are looking at individuals.
If we had capital, it has done never investors
But
it's also to come here and rely on investors from outside.
I think as a country we have capital.
as a country, we do have capital.
Where is the capital? Budget.
Why is this?
Budget to make a route. Budget to make a
I'm saying so because
Hello?
surplus is capital.
My friend in white t-shirt, you're talking too much. You. Okay. Zimbabwe, we have the capital because we have been talking. So now talk. We have capital. Why do you say so? I didn't want to laugh, but then we have capital, we have labor. What about entrepreneurship? Then I put in brackets, or I said IE, skills of the people running the economy. Okay. I will not ask whether we have that one or not. Just answer yourself. Your answer is elaborate on the correct. Let's move on. As different nations have different resources and different political ideologies, different economies are found in different parts of the world. Okay. Look, for example, people are now building, like recently in Egypt. It's a desert area.
Yes.
But now they are planting what? Is it rice? In the desert.
Yes.
But in Zimbabwe, you have all the land, it's not a desert, you have all the water. They actually made a river in a desert and started planting rice. And now it's becoming green, turning Egypt into green, a desert to green. Wow. What do you think? It's wonderful. So you have to change.
The capital.
Yes, but we have what? So different economies have what? Different economies. Okay? Some are agrarian, like Zimbabwe used to be agrarian, but now I don't know what it is. Some are non-agrarian. Some are open, some are closed. Some are capitalists, some are socialists. Okay? I don't have to ask for Zimbabwe, but just know. Okay? Because of scarcity of resources, societies cannot produce all it wants for its people. Consequently, there is need for a systematic study of how limited resources can be utilized. Okay, how limited resources can be what? Utilized. Okay, well, before you were born, that is in the 1980s, Zimbabwe used to be called what? The grain basket of Africa. I'm sure you've read it in history. Okay, we have experienced it. That's when we were growing up. It used to be called the grain basket of Africa because we used to export rice, we used to export wheat, we used to export maize to Southern Africa. Okay, but now we are actually the ones who are importing maize from other countries. Zambia used to buy maize from us. Malawi used to buy maize from us. Even South Africa, they used to buy some of their maize from Zimbabwe. Okay, but I don't know where we went wrong, but it can be recovered. I feel so. You too. And when you look, it's one that they won't travel. When you look at our city, it's one of the beautiful cities in Africa.
Which one?
Yeah.
Which one?
It's one of the beautiful cities in Africa. But now it's coming down. But it used to be one of the beautiful, it's very in the 80s. I think it was next after South Africa, then comes Zimbabwe, then comes I think Egypt and so forth.
Oh, okay.
Around.
Yeah, that can be.
Okay. Definition. Another definition. I'm trying to lighten up the atmosphere because they are too tense. Okay. Definition. Economics is the study of the behavior of an economic system in the presence of what? Scarcity of resources. I think you know this definition. I.e., study of ways in which limited resources are or should be allocated and utilized to satisfy unlimited human needs and wants. Okay. A systematic study of an economic system involves studying the structure of the economy. So we need to study the what? The structure of the system. Okay. Now, structure of an economy. Structure of an economy. During any given period, there are changes in some of the characteristics of an economy being studied, such as, okay, some of them are constant, some of them change, depending on the period. Okay, like prices in Zimbabwe, prices in this period, it's always changing. Okay, outputs, sales inventories, interest rates, exchange rates, and so forth, investment, consumption, or expenditure, availability of resources, taste, fashion, propensity to consume, propensity to buy or purchase, propensity to travel. Okay, all these they constitute what we call the structure of the economy. Okay, some of them they change, some they don't change, some change in one period, but don't change in another period, some change in another period, but they don't change in another period. Okay, they're not always fixed per se. Some what is changing here in Zimbabwe may not be changing maybe in Europe. Okay, like inflation is changing here in Zimbabwe, but in Europe inflation changes by maybe 0.000 something. Okay, but here in Zimbabwe, every day the inflation is what? Changing. But at the point it wasn't changing. There are also some features which do not change during the same period. Of course, features which may not change in one period may also change in what? In another period. Thus, it is necessary to make a distinction between variables and parameters of an economic system. Okay. Definition. The features of an economic system that do not change during any given period are collectively called the structure of the economy. Okay? So features that do not change, that's what we refer to as what? The structure of the economy. Numerical constants characterizing a structure, i.e. quantities or characteristics that do not change during any given period, are called structural parameters. Okay. So we have what? Structure of the economy, we have structural parameters. Okay, that's the numerical values. Or simply parameters of the economic system. Although the above definition of a structure may require some amplification, it suffices for our purpose. So questions can come like, what is the structure of an economy? what is social parameters? And I'm sure you can answer those questions. Understand? As I'm saying this, I'm also giving you hints. Okay. Those who have been taught by me, they now know. Quantities that change during a given period of study are called variables. So we have structure, we now have what the variables of this system. Okay, it is clear from the above that we may not be able to tell which characteristics are variables and which are parameters of the economic system until we know or specify what period we are concerned with. Okay, in this period, if you look at Zimbabwe context, what do you think are variables? What do you think are variables? Those that are changing. Prices, what else? Inflation, what else? Exchange rate, is not changing. What else? Huh? Oh, say it. What else is changing? Okay, let's continue. Economic theory is concerned with the formulation or relationship among economic variables. Economic statistics can, to a certain extent, be used to achieve this goal. Let's define what economic statistics is, and it's different from what econometrics. Economic statistics is a branch of economics which deals with the descriptive aspect of economics, such as the recording of empirical data, calculation of summary statistics, charting or plotting of the data, as well as description of obvious patterns that may be used to detect relationship among variables of the system. Okay, we're just defining what statistics is, but referring to what economy or economics. Okay, which is summary statistics. What are summary statistics? Mean, mode, variance, and so forth. Okay, then charting, histogram, bar chart, pie chart, and so forth. Then what else? Obvious patterns. You make use of time series plots and so forth. You see the patterns how it's going over time and how it's going over time. Are we together? Note that economic statistics by design does not provide measurements of the parameters of the economic system, economic relationship, and so cannot be used alone to achieve the main goals of what economics or econometrics. The main goal of economics. The main goal of economics is to hypothesize, i.e., formulate hypotheses about levels, relationships, and movements of economic variables. Unfortunately, the ideas so expressed are sometimes not clear or they are what? Vague. For example, Keynes' hypothesis about income expenditure. I said that consumption is related to what? Income. And that consumers do not consume as much as they earn. Do they consume more or do they consume less? This statement can be stated more precisely using mathematical statistics. Mathematical economics is used to quantify and make statements about economic relationships more precisely than they would if expressed verbally. Okay. Now, mathematical economics is a branch of economics in which mathematical symbols or language, i.e., algebraic expressions, equations, identities, are used to express beliefs or hypotheses about economic relationships with such clarity and consistency that meaningful conclusions about the relationships can be made. Okay. All these are definitions, one definition after another. Okay. The above example of an economic relationship between income and expenditure can be expressed algebraically, i.e., mathematically, by the linear relationship. Y is equal to A plus BX. And this equation, we call that this equation is what? Exact. Why is it exact? Because we don't have an error term there. The normal equations we know is what? Y is equal to A plus what? BX plus an error term. but this one is exact. That means the points they lie exactly on the what? On the line. Okay. It says that the expenditure will vary only if income varies, and that no other factors may cause income to what? To change. No other factors, it's just income and expenditure. One-to-one relationship. No other factors will cause it. Okay. Of which is not true. Okay. But it is common knowledge that other factors may also affect the pattern of expenditure. For example, war. If there is war, it affects the income. It also affects the expenditure. Appearance of new products on the market. Okay. Appearance of new product on the market. It also causes what? Yeah. Someone's calling me for a. Can I just answer? Hello. Can also affect expenditure. Okay. Let's say you are married. A beautiful girl comes by. It will affect your expenditure. Oh, do not agree. Do not agree. Everyone agrees. Dreams, etc. all affect what? Expenditure. Some Yuba were given exactly some amount to go and spend it at college. Then a new product appears. All the money is spent. Have you taken? Okay. Since econometrics is concerned mostly with modeling and making inferences about the parameters of the economic system or a model for it, it seems logical to start by reminding the reader what a model is in general, or also in the context of econometrics. Okay. I think this was supposed to be a first year course, not a fourth year course. All these things, they're just simple. Okay. Define what a model is. An economic model, or simply a model, is simplified imitation or representation of the real economic world, described by a set of mathematical expressions and or equations. Okay. Then econometrics is a branch of economics which deals with the measurement and evaluation of levels or movements and relationships among variables or an economic system. It is a fusion or integration of economics, mathematics, and statistics. Okay, that's what economics is all about. A fusion of what? Economics, mathematics, and what? Statistics. Now, the above example, if we factor in that a new product has come into play, then the above example, the relationship between expenditure and income can also be expressed more smartly as y is equals to what? Bx plus the error term u. Okay. Where you stand for the random factors which affect expenditure in addition to what? To income. In general, the seventh term is unobservable. You can't observe it. Okay. So the difference from the first one, which I called the exact equation, this one gets what? An error term. Okay. The observable variables whose values or levels are required to be explained or predicted are called endogenous variables. Okay. So I'm introducing another term here now, which we call what? Endogenous variables. Tutos? Endogenous what? Endogenous variable. These are the observable variables whose values or levels are required to be what? Explained. If you look at an equation here, the y's, which we normally call now, we we have this equation here. It's okay. Feel free. Now, we have this equation here. I mentioned another term here which I call endogenous variables. Okay. Before, we used to call this equation, we used to call the y's the what? Dependent variables. This was, we used to call the x's the what? Independent variables. Now, if you go to different areas, like if you go to medicine, if you go to economics, if you come to statistics, in statistics we just call them dependent variable, independent variable together. But when you go now to economics, they call this, or commerce, they call this what? The endogenous variable. Tutos? They call these ones the what? Exogenous variables. So we have endogenous variables and what? Exogenous variables. But you can take it in terms of the dependent variable. Those is a slight difference, okay? Which you will then later on. We can call this one what? The dependent variable is now called the endogenous. The independent variables are called exogenous variables. Okay. Now, the observable variables whose values are not required to be explained or predicted because they can be assumed to be determined or known in advance in such a way that they can be regarded as fixed are called exogenous variable. You can see from the definition that it's more or less like what? Independent variable. Quite clear? Okay. So we have exogenous variables, we have what? Endogenous variables. Those are the terms that will be used. Before we examine the main goals of econometrics, it is necessary to make a distinction between econometrics and statistics. It would appear from the foregoing discussion that econometric modeling is simply statistical modeling. This is not quite true. So let's get a definition of what statistics is. Statistics is a science, i.e. a method of research or investigation, which consists of controlled data collection, analysis, interpretation of the data in a manner in which logic or reason, i.e. objectivity, or generally ethical code of scientific methodology are consistently in evidence. Okay. Then, econometrics. Econometrics, however, variables can hardly be controlled. Like inflation. Can you control inflation? As they naturally vary simultaneously, or arguments cannot always be objective. Okay? Arguments cannot always be objective. They may be subjective. Okay, like some of the questions I was asking you, that's why I was saying that you are entitled to what? To your own opinion. That means it's subjective. The way you think, it's not from the way how she thinks. That's when you're dealing with econometrics now. Some of the variables are what? Subjective. In economics, or somebody can come and say that, oh, inflation here is not growing. It's okay, it's constant. Someone can say inflation is going up. That's why the point is last year or last year, but one. All the mutual they get their own what? Inflation figures. Then Zimstat, they had their own what? Inflation figures. Those two were different. But same country, same economy. But they had different figures. How they were calculated them, I don't know. But they end up being different. So that one of them had to be banned to say you no longer publish inflation figures. Okay, because it was not subjective. Okay, so let's move on. Econometrics and statistics, however, agree in some areas of the analysis. For example, when you are performing, when you are doing some analysis. The problem with internet is campus wide, so I don't have to worry. But still say I'm sorry to your colleagues. Okay. So when it comes to analysis, normally when you are performing some analysis, statistical whatever, you have to do these things. There is what is called model specification or identification. You identify the model using your data set. Then you estimate the parameters that you have. Like this one here. We have specified our model as this one. Do you get it? Or if identified our model as this one here. Then the next one is what? estimation of the parameters now. The parameters are these ones, beta 1, beta 1, beta 2. These are our parameters. Now you estimated them. Do you get it? That is estimation. Now you fit. After fitting, you perform what? Diagnosis checking. Diagnosis checking, that's now we are what? Testing the assumptions that I spoke about. Do you get it? Whether those assumptions they hold or not. If the assumptions hold, or when you perform diagnosis checking, ensure that your model is adequate or is good, then you adopt that model and you make use of that model. Okay. Then further you can do what? Forecasting, prediction, and so on. All together. So always when you are doing analysis, perform this: specification, estimation, fitting, diagnostic checking. Tutors. Further, an econometric model, like any other statistical model, must be relevant, simple, and have a high forecasting power. So try and use a what? Relevant model, a simple model, and a high forecasting power model. Don't try and complicate your life by trying to get complicated models. Okay. Oh, this part here. You can read one by one, it's not. Goals of econometrics. Econometrics has 4 main goals. These are description, explaining, and prediction, and planning and control. Okay. Which I will assume you can read on your own. They are quite straightforward. Okay. Now let's look at some time series and some econometric models. Let's look at those models. Okay, in this section we give some examples of econometric models that are used or can be used to model economic systems. Econometric models can be divided into 2 types. We have the first category, that is consists of those models in which some variables called explanatory, causal, independent, or predictor variables are. You can see that we're describing the what. So these are different terms to describe what. We can call it what? Explanatory. No, we are describing the axis. Tutors, we are describing the axis. So we can call them the explanatory. We can call them the what? The causal. We can call them the what? Independent. We can call them the what? Predictor variables. So these names can be used interchangeably. Are we together? But just know that we are talking about these variables here. The ones on the right side of your equation. Okay. That variables that are known or susceptible to be related to or to cause the variables of interest. So these ones, they cause the variable of interest. Once they okay, they cause this one to change. Just interest in the model to explain or predict the dependent variable. Okay, that's the first category. Then the second category consists of time series models in which historical or correlation structures is used to make inference about the unknowns of the system, in particular forecasting future values. Okay, we have done the definition which has to do with the first category. You've done also what? Time series. Okay, so you've done these 2 categories. So you're safe. We are just applying this one now to what? To economics. Okay. For this reason, this section is split into 2 subsections dealing with each of these divisions separately. It is important to note that in general, a good or satisfactory econometric model will entail use of both approaches to econometric modeling. So you can use both approaches. We have the causal models. As indicated earlier, econometric modeling is concerned with establishing or measuring economic relationships. Further, it was indicated that economic models serve 2 main purposes, namely, to support existing theory when making decisions. To support what? Existing theory when making decisions. Then, number 2, to suggest new economic theory that can be used to explain observed behavioral patterns. The following examples, together with the exercise given at the end of this section, are designed to give the reader a firm grasp of the understanding of econometric procedures. It will be evident from these examples that time series procedures are part and parcel of econometric modeling. Oh, I'm just saying number 2 here. Case model of what? For consumption. Okay. And it gives a relationship between what? Income and what? Expenditure. If income is 1x and expenditure is y, the model states that y is equal to a plus bx. This is a case model for what? Consumption. Okay. And that the marginal propensity to consume, MPC, which is the rate of change of y with respect to x, is less than 1. Okay. And here we are talking about the B. That's the MPC, marginal propensity to consume. I1 model for stock or for share prices. Okay. The difference between those from the sciences and those from the economics. In economics, they have a model already. Like here, they just say income and expenditure. The relationship is given by what? Y is equal to a plus bx. So when they have data set of income and expenditure, this is the model that they are going to use. Okay? Whereas here, we have to find out a good model that fits the data well. But there they just know that income and expenditure, this is the relationship, and this is the equation that we're going to use. And they just apply that equation. Whether the data fits well or doesn't fit well, it's not their problem. They just know that somebody has come up with this model. When income is there, when expenditure is there, this is what they are going to fit. But here we have to find out an adequate model, a good model. That's why we have to perform diagnostic checking and so forth to come up with what? An adequate model or a good model. It was. Now, another model that they know. If they have stocks, data with stocks, of stocks, if they have data of share prices, what is the model that they are going to fit? It's an I1 model. I1 model is integration of order 1. Times this is coming now. We are talking about the I1. Integrated of order 1. Where here, we normally say ID. ID, where D is the order of what? Difference. You still remember from time series. So this one's an I1 model. 1 stands for the order of what? Difference. We have to difference ourselves. Okay. If we have an equation y, t. If we have a series y, t. Difference in ones, what does it mean? We take the elective values, minus 1, t minus 1. That's first difference. We subtract the elective values of what? Then we have to obtain this. We can call it set 2. It's equal to this. We have difference ones. If you still remember, if I can take you recap, yt is equal to b, yt minus b, yt. What is b? Backward shift operator. Which is just the same as what? 1 minus b, yt. That's the first difference from time series. Just a recap. Okay? So, before I continue confusing you, let's go back to the I1 model. So you see our Y1 model, I1 model for stocks, share prices, and so forth. In economics, they'll just say, if they see data set with stocks, they just say it's an I1 model. No matter what, they just say it's an I1 model. Or if they say data set for what? Share prices, they just say it's what? I1 model. What is it true? In this sense. It can be true, it cannot be true. Depending. But here we will try and analyze it and see the best model. That's why we perform time series and come up with the best model to model the stocks, to model the share prices, and perform diagnostic checking and come up with the appropriate model or a good model. Okay. So that's the I1 model. Yt is equal to Yt minus 1 plus the error term ut, which is this one here. That is the price of a stock today is equal to the price to its price yesterday plus some disturbance term ut. That's how they define it. A stock or a share is a written agreement by means of which an individual or company can share ownership of another company by being a shareholder. A stock is usually sold and or purchased through a facilitator called stock broker. Another model. Again, when they see inflation, they say it's what? I1 model. That's why we are saying the I1 model of what? Inflation. Like stocks or share prices, inflation is also widely believed to satisfy the model Yt is also Yt minus 1 plus the error term ut. Okay, so when you look at stocks, shares, share prices, inflation, they all follow what? An I1 model. Okay. Balance of payment. Balance of payment. In macroeconomics, the balance of payment is the difference between the total exports and total imports. That's the balance of payment. Okay? Which is given by that equation here. There. ut is equal to Yt minus xt. And is a stationary time since it means 0, even though exports and imports may not be stationary themselves. That's the balance of payment. We have money supply and money velocity. Okay. From the foregoing discussion, it is clear that econometric modeling involves use of many concepts from time series. Okay, like here I've mentioned already the I1, I2, and so forth. Okay, such as the concept of stationarity, auto-regression, etc. Thus, our discussion cannot be complete without reference to time series, since there are more detailed discussion of this concept is given in the post-time series analysis. Here, we present a summary of the ideas, in particular those that are relevant or frequently used in econometrics. Time series. So I will not bother myself going into details of time series models. I will just run through because we've done this. It's a course that we've done already at level 2. So definition of the time series, you know, and most of you watch. You say first class or ding? You got my ding. This is all. Except that you do. So that's time series. Just a recap of time series. You still remember all this. Second order stationarity. Where the mean does not depend on t, the values does not depend on values does not depend on t. This is what second order stationary or weakly stationary. Okay? Then the auto correlation, that is gamma k over gamma naught. Then the partial auto correlation, you still remember all these things. I'm not making a lot of noise. You did what? You did 2 times 3. So what are you doing here? Which program are you doing? Apply. So you jumped over and you didn't do times 6. How many did you do times 6? That how many didn't do? Don't say test. That's what you're saying. I didn't do it. That's why you're making a lot of noise. Anyway, don't worry. I will not ask something that is beyond. Okay. Moving average process of order Q. But try and see your colleagues and they will explain this to you. I explained to them very clear and the board marking. Unless if I have to take place my things. Moving average process of order Q, MAQ. Okay, you still remember those ones? You still remember them? Okay, MAQ. Then autoregressive process of order P, ARP. You still remember? Then autoregressive moving average process AMA PQ. You still remember that? Just say yes. The recipients to have a shadow memory of it. Then that's the PACF, ACF, and so forth. Now, take note that the characteristic feature of most economic variables is that they are non-stationary. I'm waiting for you to finish what you're saying. Are you done? Are you done? The two of you, you're done? I can continue now. While there is essentially one to be stationary, there are a myriad of ways in which a series may be non-stationary. However, most economic variables tend to be non-stationary in the essential one way. Okay? We're talking about stationarity here. Now, definition. A series or a process YT is integrated of order 1. Denoted YT is equal to I1. Denoted by YT is I1 if it is non-stationary, but its first difference is stationary. So this is YT is non-stationary. But after differencing it, we get a series ZT. We are saying that this one, YT, is non-stationary. But if first difference is stationary, then says what? I1. Sometimes after differencing once, this one's still non-stationary. Then you difference it again. You get it. To get another series, which you can call XT. So if XT becomes stationary after the differentiation, YT twice, then you say XT is what? Integrated of order 2. But if YT is stationary already, we don't have to differentiate. Okay? That means it's what? Integrated of order 0. Integrated of order 0. What is this figure? Is it clear? Alright, so I can move on. Now, example. I've been talking and doing it. So let's do an example. We just set the concept of I1, I0, and so forth. Yeah, tell you. Don't disturb. Okay. So we are saying that YT, that's our system that we have. It can be inflation, it can be stocks, it can be what here. Are we together? So now, we can differentiate this series once, or several times, or 2 times, or 3 times, depending. Okay? So we can have an I0. It implies that YT is stationary. And we can have I1. This implies that we have to difference once. YT. This one becomes what? That means we are differencing YT once. You still remember B, the backward shift operator. So you're differencing this once, then it becomes what? Stationary. Then I2. What does it imply? 1 minus B to the power of 2 YT. It's now what? Stationary. This is we can have I3, that means 1 minus B to the power of what? 3. I hope I'm not assuming things that you don't know. You still remember this? Yeah. Backward shift operator and so on. Okay. So now suppose an economic time series satisfies the second order auto-regressive model. Yt is equal to 1.5 Yt minus 1 minus 0.5 Yt minus 2 plus At. Show that Yt is I1. Show that Yt is what? I1. That means we have to difference it once. Then check whether it's stationary or not. You still remember how to do this? I still remember giving questions like this in time series. Can you do it? So what do we do? Yt is equal to 1.5 Yt minus 1. This is what? Minus 0.5 Yt minus 2. Then what? Plus At. You still remember that the At is what? White noise. So the question is, show that Yt is I1. Show that Yt is I1. There are two ways of showing it. That is I1. Number one, we can just simply subtract Yt minus 1 here. That's the first difference. Once to subtract this side, we also have to subtract this side. And then to obtain another series. After obtaining that series, we try and see whether that series is itself. Okay? Another method is just to find the characteristic polynomial of this. If one of the roots is 1, it entails that it's an I1. Okay, so which method? First or second? First. So with first method now, what we need to do, just subtract Yt minus 1 here, and also subtract Yt minus 1 here. I don't change anything. That is what? So we say Yt minus Yt minus 1 is equal to 1.5 Yt minus 1 minus Yt minus 1 minus 0.5 Yt minus 2 plus 18. Is that correct? This one we can split into 2. We can have Yt minus 1. Then what? Minus no. You don't see where I'm going. So something like that. What was that? 0.5. Yt minus 1. Then minus what? Plus, which is equal to 0.5. Then so if we let this part here be equal to ZT, which is the first difference. So what is this part here? ZT minus. So what do we end up with? ZT is equal to 0.5 ZT minus 1 plus 80. So now the next thing is to show whether this one is stationary or not. Because we have obtained already first difference, which is ZT. So if this one's stationary, then you say yt is what? I1. Because it differs only once. So how do you show that this one is stationary? Let's introduce the backward shift operator, find the characteristic polynomial, and also find the roots of that. Okay. So now, to show stationarity, we take this one to the other side and introduce the backward shift operator, if you still remember. So what does it imply? Zt minus 0.5 b zt is equal to 18. The Torah is the guy to b. B zt minus 1 just the same as what? Z. B zt is equal to zt minus 1. If you still remember. And this one. So now, after this now, let's factor out zt. 1 minus 0.5 b zt is what? 18. Is that correct? Now let's take this. That's the characteristic polynomial. Our characteristic polynomial. And equate to 0. And equate to 0. And so for b, what do you get? What is b? One minus 0.5 b is equal to 0, which implies that b is equal to 2. Someone is looking for a calculator to calculate that. So b is equal to 2. So we say it's stationary when the roots that we have obtained lie outside a unit circle. So does 2 lie outside the unit circle? Yes, no? Yes. So what does it imply? Z is what? Stationary. So after differencing ones, we obtain a series with ZT, which is stationary. Which implies that the yt is a what? One second. Okay, let's move on. So I'm saying that yt is not stationary, but the first difference is what? Stationary. In practice, of course, one does not know whether or not a series is I1. The assumption must be tested before further analysis. So if you have a data set now, you have to test the assumption before you do any further analysis. That may depend on the stationarity or non-stationarity assumption. A simple test for stationarity against that of non-stationarity is provided by the Dick-Fuller test. There are other tests, but the one we are going to use here is just what? Dick-Fuller test, due by Dick and Fuller, 1979. That's a long time ago. The test procedure is outlined below. That's the Dick-Fuller test. Dick-Fuller test. Okay. The econometric model, yt is equal to a plus b, yt minus 1 plus the other term ut. The hypothesis to be tested is b is equal to 1, i.e., in other words, we're saying b is what? Unity. I enjoy when someone comes in the race and I just write someone comes in the race. My friend, you can come and help me here. Thank you. I'm going all that. You're laughing when I say I'm growing old and older. I was once like you. You will be like me1 at a point. How old I am? Even if you yourself do not Many you don't mind, but many you don't mind. Alright. This is the deep fuller test. There are other tests to test for stationarity. Okay? There are other tests to test for stationarity. But the one I'm explaining here is that deep fuller so that you get an understanding of what testing for stationarity. So we have an equation there. I don't have to write everything down. We see it. The econometric model is what yt is equal to a plus b yt minus 1 plus u3. Let me write, because I have someone to be erasing. A plus what? B yt minus 1 plus the error term what? ut. So this model is stationary. What is it stationary? Or we can say this model is an I1 integrated to folder 1. When our B here, this B here is 1. And so that we can end up with what? This, if it's equal to 1, we end up just with yt minus 1. Then we can take this yt minus 1 to the other side. Then it becomes yt minus 1. So that's the first difference. It's equal to a plus the error term ut. And so it's integrated to folder 1 if B is equal to 1. How is this figure? Okay. I'm trying to complicate things so that it becomes more complicated, but it's like simple. Now, the hypothesis will be tested. Now we need to test. If you are testing for just a unit root here, we are testing that B is equal to 1. And so that's why our hypothesis there is that what H naught B is equal to 1. That is integrated to folder 1. Versus this B is less than what? 1. Okay? Is it clear? So when we accept H naught, that means we are saying that yt is I1. When we reject H naught, we are saying that yt is what? I0. Is it clear? To obtain the statistics, regress yt on y1. If we obtain a regression line of yt and y1, okay? Or equivalent to regress the difference yt is equal z is equal to yt minus 1 on the negative values of yt. The test statistics is the usual t ratio. Okay. Once you regress, you obtain beta head. Understand? After performing regression, you obtain beta head, and you want to find also the standard error of the beta head. Okay. So we obtain now the test statistic. Is t is equal to our estimate from the regression line, which is what? Beta head minus 1 divided by standard error of beta head, SB. Are we together? Okay. So when we have this, we have the standard error of this, you can obtain the t. Okay. Where SB is standard error of beta head from the regression. The hypothesis of the unit root IE and I1 series is rejected in favor of the stationarity for small values of t. Okay. We reject H naught for small values of what? T. It's the opposite of what you usually know. We reject for what? Large values of t. Now we are saying reject for what? Small values of t. I.e. the 1%, 5%, and 10% critical values for the one-sided tests are displayed in the table below. You don't have them in our statistical tables. So normally they will be provided. Okay, the critical values. It is important to observe that the asymptotic distribution of the statistics t when b is equal to 1 is neither normal or symmetric, so that the standard normal tables or t tables cannot be used for inference. So these are the critical values at 1%, 5%, and 10%. Okay. Too close. Spectrum and this application in econometrics. Did you do this in time series? You still remember? And there was a particular question I used to like in this. But we will not bother ourselves. Just know that the spectrum in this application in econometrics. That's all. Steps in the econometric model, we've done this already. Specification, estimation, diagnostic checking, and inference. What's the news about? Now, summary of the unit. The end. Integration status of the following models and the order of integration where possible. Okay. So, part C. Can you quickly do that one? Then during your own spare time, do A and B. Can you quickly do part C? Plus what? Error 10. Now let's take this to the other side and introduce the backward shift operator. What do we do? YT minus 0.6. 0.6. B YT minus 1 is equal to 80. Then what are we going to do? Factor out YT. 1 minus 0.6 B YT is equal to this one's supposed to be YT is equal to 80. Then this is our characteristic polynomial. This is what equal to 0, and so for B. What do you end up with? B is equal to 1.67. And 1.67, does it lie inside the circle or outside? So what does it mean? Stationary. That means YT is stationary. So when YT is stationary, what is its mode of integration? 0. Outside this space. That means YT is I